Hello everyone. In this video, we are going to discuss applied chemistry for CS stream, module 3. Super important questions. These are the 6 questions that are most repeated and most important. Uh, so let's get started. Explain corrosion control by anodization and sacrificial anodic method. Here, anode, you need to remember one thing. Anode means it goes under corrosion, and cathode doesn't go under corrosion and gets protected from the corrosion. Anode goes under corrosion. This you need to remember. What? Like anode goes under corrosion. This is the main thing you need to remember. So corrosion control by anodization. Anodization. Anodization is the process of forming a protective oxide layer on the metal surface by electrolysis. So it forms a protective oxide layer on the metal by electrolysis. Anodization. So here process have 3 steps. The metal, example aluminum, is made the anode, and the steel copper is used as cathode. The electrolyte used is 15 to 10% chromic acid at 30 to 40 degree at applied potential of 0 to 40 volt. The reaction forms at aluminum oxide layer, which provides corrosion resistance. So basically here anode is aluminum is made anode and it is being protected from corrosion. Okay, so this is the reaction you need to write here. Advantages: increases corrosion resistance and mechanical strength of aluminum. Moving to the second, sacrificial anodic method. So name itself tells sacrificial anodic method. Here one metal sacrifices itself to save the another metal from being corroded. A more reactive metal, example zinc, magnesium, aluminum, is connected to the metal to be protected using a metallic wire. So here you can see the diagram. You need to draw the diagram which consists of mass. The sacrificial metal acts as anode. As I told, anode always undergoes corrosion, whereas cathode remains protected. The sacrificial metal acts as anode and undergoes corrosion, while the protected metal remains the same. So here the sacrificial metal is zinc and it is acting as anode. So it goes under corrosion, whereas the steel pipe which acts as cathode doesn't go under corrosion. Okay. So coming to the next question, we have explained the construction and working of calomel electrode. This is the most repeated question. Working and construction of calomel electrode. So construction requires 3 steps. So this is the diagram: a glass tube with 2 side tubes filled with saturated KCl solution. This is the glass tube with 2 side tubes. So these are the 2 side tubes, and this is the solution filled with saturated KCl solution. The bottom contains mercury and calomel. So this is containing mercury and calomel plus calomel paste. Okay. A platinum wire provides electrical content. The wire you can see here is the platinum wire. Coming to the working of this electrode, it functions as a reference electrode with known potential. The potential is known here, and the calomel electrode behaves as anode or cathode depending upon the nature of another electrode. So the electrode reaction, here we have calomel plus 2 electrons, which is equal to mercury chloride, mercury plus chloride. You need to write this equation. Application used in potentiometric measurement and pH determination. And potentiometric measurement and pH determination. Explain the construction and working of glass electrode. So coming to the glass electrode, this is the equation that is in video handbook. You can write this equation and get grab extra marks. Video handbook page. So coming to the definition of glass electrode: an ion selective electrode used for pH determination. It is an ion selective electrode that is used for pH determination. pH means power of hydrogen, which is used to detect uh, like acidic or basic nature a solution has or any material. Construction: a thin wall glass bulb filled with point M HCl with Ag or AgCl. Ag means silver or silver chloride inside. So you can see here a glass bulb, thin glass bulb with Ag or AgCl electrode. You need to draw this diagram as it consists of marks. Working. The potential developed across the glass member depends on H plus ion concentration. So the potential developed across the glass member depends upon the H plus ion. H plus means acidic ion concentration. And you need to write this uh, equation to grab marks. Yeah, better writing equation than this. You can write the equation provided in VTU handbook for calculation of pH. Application, as we already discussed, it is an ion selective electrode. It is used to measure pH, potentiometric titration, and research. You need to draw this diagram, and you can write this equation which is present in handbook, video handbook, which will be provided for you during the exam, and it is page number 5. Coming to the next question, we have galvanization and its application. Galvanization is another method to prevent a metal from being corroded. So galvanization is a coating of zinc on iron or steel by the hot dip process to prevent corrosion. So iron corrosion or steel corrosion is prevented by coating it with zinc. This process is known as galvanization. Steps involved are: the iron sheet is cleaned. So the iron which is being coated will be cleaned through greased, acid waste, and dried. It is dipped into a molten zinc at 419 degree. This is important. You need to mention the degree with NH4Cl flux to prevent oxidation. These are the process here. First, the iron sheet is uh, goes under organic solvent. Later, it goes under dilute sulfuric acid, then distilled water and hot air, and the zinc molten at 419 degree. Later, hot rollers, then the galvanized iron sheet is thrown out. You need to draw this diagram. Not need to draw in detail, just draw it with draw four troughs and a straight pipe going deep from all the four pipes. Later you just mark it galvanized iron sheet. Remember to write this organic solvent, dilute sulfuric acid, distilled water, and molten of zinc. You will get full marks on this question. Applications used in roofs, pipelines, car bodies, and construction. This is used in uh, roof to prevent corrosion, pipelines, and also in car bodies recently. Coming to the next question, we have explain differential metal corrosion and waterline corrosion. Waterline corrosion is also known as differential aeration corrosion, and differential metallic corrosion is known as galvanic corrosion. Okay. Differential metal corrosion occurs when a metal is exposed to different oxygen concentration. Like one metal is exposed to one concentration of oxygen and the other metal is exposed to other concentration of lead. Which the metal which is exposed to low oxygen area becomes anode. And we know that anode means the one which gets corroded. The metal which is exposed to low oxygen area becomes anode and gets corroded. The metal which is exposed to high oxygen area becomes cathode and it is protected from being corroded. The oxygen concentration between difference creates a potential difference leading to the corrosion. So here you can write this example to get the marks. Just write the iron metal, copper metal, anodic area, cathodic area. So the mark as anodic area gets corroded and the cathodic area doesn't get corroded. So waterline corrosion. Waterline corrosion is an example for differential aeration. So this is main waterline corrosion is mainly seen in steel tanks. Steel tank partially filled with water. Like the steel tank is not totally filled. Here we have water and the upper part of the tank is empty. So the lower part which is underwater has less oxygen supply and becomes anode. Anode means it gets corroded. The lower part is exposed to less oxygen and acts as anode and get corroded. The upper part above the water here above the water has more oxygen supply and it's become cathodic and gets protected. So you can write this reaction result where the rust formation occurs just below the water line. So rust formation occurs here at the surface, the area which is underwater. Okay, so moving to the next question, we have electrochemical theory of corrosion, taking iron as an example. The invigilator will, the question will be like taking iron as example. So we need to write the theory points of the electrochemical theory. Later we need to take the iron as example. So Electrochemical theory has 4 points. Corrosion occurs due to galvanic cell formation on the metal surface. Galvanic cell forms on the metal surface, then the corrosion occurs. Anodic region undergoes oxidation and gets corroded. As we talked before, anodic region goes under oxidation and gets corroded, while the cathodic region undergoes reduction and it is protected. The metal which undergoes oxidation gets corroded by a oxidized layer on it. The metal which undergoes reduction means loss of oxygen is protected. Electron transfer from anode to cathode. During corrosion, the electrons are transferred from anode to cathode. Oxidation occurs at anode and reduction occurs at cathode, leading the metal deterioration. So here we need to write this taking iron as an example in the presence of moist air anodic reaction. So we need to write these both reactions. The iron is initially like Fe normal, later it gets anodized, then the oxide layer form and later it becomes corroded. And also you can skip it, like you write this equation and later write the corrosion equation given in the handbook of the video provided to you during exam. It is in page number 4. Just write this equation if you can't remember. Coming to the last question, we have what is CPR? CPR. What is CPR? CPR is corrosion penetration rate. Corrosion penetration rate means a rate at which the metal decreases due to corrosion. Loss of weight in the metal due to corrosion is known as corrosion penetration rate. It is expressed in terms of thickness loss per unit time. Thickness loss per unit time. Okay, so this is the numerical every time asked, and here easily you can grab 7 marks. A thick, a thick brace sheet of area 100 inches square is exposed to moist air. After 1 year of period, it was found to experience a weight loss of 75 gram due to corrosion. If the density of the brass is 2.52 gram per centimeter cube, calculate CPR in MPY and MMPY. So basically, we don't need to remember any of the formula nor the units that we are going to plot in MPY and MMPY. It is given in the video handbook in the page number, like I guess page number 4. This is the thing that is given in the video handbook formula handbook sheet. So here it is also given in, if you are calculating in MMPY, the constant value is also given and the area it should be in inch square for MPY. For MMPY, we need to convert it into centimeter square. That's the only difference, and the difference is in K and in area. Okay, so let's get started. So the formula is CPR equal to K into W divided by DAT, where K stands for constant, 534 MP for MPY and 87.6 for MMPY. Here W stands for weight loss. The weight loss here is 75 gram. And density. Density is given, which is 2.52. We don't need to change this, and we need to convert the weight loss into milligram. And coming to exposed area exposed, like which area is exposed to air. Here 100 inch square area is exposed to air. Here we need to convert here we need to convert it to centimeter square for MMPY and keep it same for MPY. Time it should be in hours. Here they are given 1 year. 1 year, in 1 year we have 365 days. In one day we have 24 hours, so 365 into 24, we will get it into hours. So given data is weight loss is 75 gram, which we need to convert into milligram. So multiply it by 1000, we get 75,000 milligram. Area is 100 inch square. Keep as it is for MPY, but we need to convert it to centimeter square for MMPY. 1 inch is 6.452 centimeter square. So multiply it with 6.452 to get it into centimeter square. Multiplied the given 100 or anything inches value into 6.452. Just you need to remember this value, which is 6.452, to convert it into centimeter square. Okay, density remains the same. For 1 year we have 365 days. In each day we have 24 hours, so it will be 8760 hours. So coming to the problem, just write down the formula given in the VTU handbook. It is given in page number 4, and VTU handbook will be provided in examination. If they don't provide, you need to ask and get it from them. So writing the K value for MPY, we need to K value here. It is given 534, and weight is we got that 75,000 milligram, divided by density is 2.52, which we need to keep it same, and into, like for MPY, notice here it is it is mentioned that we need to take the area in inch square, so don't need to change anything, just take 100 into time should be taken in hours, and we have calculated it is coming around 8760 hours. So plot all the values, evaluate. On evaluating the numerator and the denominator, we are going to get 18.4 mpy. Now coming to mmpy. MMPY stands for millimeter per year. Okay, corrosion penetration rate. Here the K value gets changed. Just refer this table given in the handbook. For MMPY, the K value is given as 87.6, right? 87.6, and the weight remains the same, 75,000 milligram. Density also remains the same. But when we are writing the area, now in MMPY, we need to convert it into centimeter square. So we have converted it into centimeter square just by multiplying 6.452. So we are getting 645.16. Write it down here, and the time remains the same. It is in hours. So we got it in 8760. Anything they have given in year, just multiply with the days and with the hours. We're gonna get the required hour. So on calculating the numerator and denominator, we are going to get 0.462. This so see friends, this is really easy. So don't skip this numerical and just write the numerical. You will easily be getting 7 marks, and also the formula and also the thing that needs to be plotted are also mentioned in video handbook. So try to attend this numerical, and the numerical most repeated one is the brace formula. Just remember to change the inch square into centimeter square, and also to change the constant depending upon the mpy or mmpy. So this completes this module. Now just if you need any pdf, just comment on pdf. I will be providing the link. Thank you for